Welcome to this episode of Robert's Creative Chronicles. So today we'll be solving this question, which states that evaluate the following integrals. These are the integrals. So solution. We'll start with the first one. So in this one, we're going to use simple substitution technique of integrating functions, because you can see that this function x plus 1 and x squared plus 2x minus 1, they are functions of x. And if you differentiate one of these functions, which is the second one, the down one, you get a function that will cancel this one. So we cannot use direct integration, obviously. So the only method we can use here is simple substitution. Likewise here also, because when we differentiate this other function, x and x will cancel here. This one also, if we differentiate sine, to give us what? Cos. So cos will cancel. So in all these functions, we can use substitution to do it. That is simple substitution method. We can't use direct integration in these ones, and it's not integration by parts. It's not. We cannot also use trigonometric substitution. It's not partial fraction. So the only method we can use here is simple substitution. So now we will do it. So we'll substitute t as the down one, so that when we differentiate it, we can get a function that will cancel this one. Because if we pick x plus 1 as our t now, we will get 1 as the derivative. So 1 will not cancel any function of x. So we want a function that when we select it, we can cancel other functions of x. So t will be equals to x squared plus 2x minus 1. So the x is what? 2x plus 2. Now if you factorize this becomes what? 2x plus 1. So this becomes 2x plus 1. You can see that x plus 1 can cancel this x plus 1. So normally we'll make the x the subject of the formula. But to make things easy, we'll make x plus 1 the x the subject of the formula. So we can just substitute it here directly. So it will become half the t will be equals to x plus 1 dx. As you take this to the other side and bring these two down here, you get half the t is equals to x plus 1 dx. So now we can substitute the values of t here. We will get what? Integral. Here we have a value for it, so we can put 1 here over, what's this? Is t squared, then times, this we can remove it because this and this are multiplying this fraction. So we substitute them here. So if we substitute, and the substitute of this is this, so we'll times it, half the t. So it has replaced this 2 now. So now it becomes what? We'll factor out, or we'll bring out half. So it becomes 1 over t squared dt. So this becomes half integral of t minus 2 dt. So if we integrate t minus 2, we'll get what? T minus 2 is what? It will be t minus 2 plus 1 over minus 2 plus 1. Then there's half. There's this half. Then plus c. So now this becomes what? 1 minus 2 is minus 1. Minus 1. This one also is minus 1, so we can put the minus here. Then multiplied by 1 over 2 plus c. So this becomes what again? This t minus 1 is what? T minus 1 is the same thing as 1 over t. So it will become minus 1 over 2t plus c. Then we'll substitute t, because t raised to the power of minus 1 is what? Is 1 over t. So 1 over t times 1 over 2 is what? Minus 1 over 2t. Then now the integral becomes what? Minus 1 over 2, then t is what? x squared plus 2x minus 1 plus c. This is the final answer. So the integral of this function is this. Now let's move to the second one. We'll now substitute this as our t, because with that we will get an x that will cancel this. So if we take x as t now, there will be problem. So t now is equal to x squared minus 3. So the x is what? Is 2x. So now we will make x dx the subject of the formula to make things easy. So x dx will be equal to what? You take the x to the right hand side and bring down 2. So it becomes half the t. So x dx is half the t. Then now we substitute t in this integral. So it becomes what? Integral of t raised to the power of 4 times half the t to represent x dx. So then we simplify it. This becomes 1 over 2 integral of t for dt. So now we'll find the integral of t raised to the power of 4 is t5 over 5 plus c. So this becomes 1 over 10. 2 times 5 is 10. Then what's t? T is x squared minus 3 raised to the power of 5 plus c. So now this is the integral of this function. So this is the final answer. Then let's move to the third one. So now here's the third one. So now in this one we're going to substitute t as sine x plus 1, because when we differentiate it to be cos x, and to be easy to cancel since this one is outside. But if we take t as cos x now, we'll get negative sine x, but it will be difficult for you to cancel this one since there is a square root on it. So it's easier for you to take sine x plus 1 as t, because it will be easier for you to cancel cos x. So now we'll say t is equals to sine x plus 1. Then we'll find the derivative. This becomes the t over the x is equals to what? Cos x. So we'll make, instead of making the x the subject of the formula, we'll make cos x dx the subject of the formula to make things easy for ourselves. So it will be, the t will be equals to cos x dx. So now we can substitute the values. So now we can substitute the values of t in this integral. It will be cos x dx is outside. So we have already found the value for cos x dx, which is the t. So now it will be root of t times dt. Since dt means cos x, since the t is equals to cos x dx, and root of t sine x plus 1 is t. So root of t. So now this becomes t raised to the power of half dt. Then to integrate this becomes what? To be t 1 over 2 plus 1 over 1 over 2 plus 1 plus c. So now what's 1 over 2 plus 1? 1 over 2 plus 1 is 3 over 2. So this will be equals to t 3 over 2 over 3 over 2 plus c. So this becomes, the inverse of 3 over 2 is 2 over 3. So 2 over 3 t raised to the power of 3 over 2 plus c. Then we can substitute the value of t here. So t is what? T is sine x plus 1. So this becomes 2 over 3 sine x plus 1 raised to the power of 3 over 2 plus c. So the integral of this function is this. This is the final answer. So we have evaluated all the 3 integrals given in the question. I hope you understood this episode. If you have any question, feel free to contact me using my WhatsApp or email written in the description below, or you can write them in the comment section. Thank you for watching. Please don't forget to like, share and subscribe to my channel, and hit the notification bell to get notified as soon as I drop a new video. Thanks.